This is the program for stepper motor interface. You can see that we have written move A comma hash 66H, and then from accumulator we are moving it into port 1. This means that the accumulator content, whatever we are moving to port 1, is the value that we are sending to stepper motor. What is the value that we are now sending to stepper motor? It is 66H. So if 66H is coming, only P1.7, P1.6, P1.5, P1.4, only 4-bit value will enter into the stepper motor. Let's see what is that P1.7, P1.6, P1.5, P1.4. 66H means you can see that 0110 is 6 and another 6 is 0110. So this is the value that we are trying to send. Whatever we send to P1.0 to P1.3, it is not reaching the stepper motor. But what is getting into the stepper motor is only P1.7 to P1.4, right? Okay. Now, in the earlier diagram, I had shown you that there are 4 stators: A, D, B, C. Please remember, it is not in the sequence A, B, C, D. It is in A, D, B and C. So the windings are like this. So what example that we are going to take here is, I'll take 2 windings to energize the rotor. So when I energize P1.7 and P1.6, it will stand here. Immediately I'll have to energize D and B stators. So it will rotate like this. It will come between P1.5 to P1.6. Again I'll energize B and C this time, so that it will rotate like this. So it will stand between 1 and P1.5 and P1.4. Again I'll energize C and A, so that it will stand like this. Again I'll energize A and D, so that it will come like this. So if I energize in this sequence, please mind it. If I energize in this sequence, it is going to be a clockwise rotation of the stepper motor, right? Okay. So initial value that I have taken is now 66H, which is 0110 and 0110. So if this 6 enters into the stepper motor, P1.6 and P1.5 gets energized. P1.6 is what? Winding D. And P1.5 is what? P1.5 is winding B. So the rotor stands like this in between the two. Fine. So what should I do if I would want the rotor to rotate like this now? I need to send my next sequence so that P1.5 is energized, P1.4 is energized. I need to make my next sequence such that I energize winding B and winding C. Therefore, P1.5 and P1.4 I should make it 1. P1.5 and P1.4 I should make it 1. And what should be A and B? They should be off. They need to be de-energized. Means P1.7 and P1.6 needs to be de-energized. So from this sequence to come to this sequence, what should I do? See here. Observe like this. What have I done now? Only thing is we have shifted each bit to the left. So can I shift left by 1 bit, rotate left, RL I can make use of it. See here, rotate left accumulator, right? So by doing rotate left the accumulator content, I can shift the port 1 content to the left by 1 bit each sequence. So what will this sequence become now? This sequence will become 0, 0, 1, 1, right? Each and every bit from port P1.7 to P1.0, each and every bit is shifted left by 1 bit, right? So that now the rotor from here has come here. What should I do next? I should make the rotor further rotate between C and A. For that, what value do I need to give? I need to energize P1.4 and P1.7. So P1.4 and P1.7. What should be the other two? Should be de-energized, right? So this sequence, again you can see that if I write the same 1 0 0 1, whatever is here I write the same the next 4 bit as well, right? In that case you can again see that from this sequence again I have shifted the sequence to the left by 1 bit only. So each time I am sending the sequence, I am shifting it left, sending the sequence, shifting it left, sending the sequence. Okay, so you can see that now it is these two energized, C and A is energized now, that is P1.7 and P1.4. Next, what should I do? The rotor should rotate like this and stand here. So for that I should energize A and D. To energize A and D, what sequence should I send? P1.7 and P1.6 I should energize. P1.7 and P1.6 I'll energize, the other two de-energize. The same I'll write 1 1 0 0. You can see that these sequences, the first sequence and the second sequence, what is the similarity? Only thing is second sequence is shifted, shift of first sequence by 1 bit to the left. What is third sequence? Third sequence is again shift left of second sequence by 1 bit. What is fourth sequence? Again it is shift left by 1 bit of third sequence. So simply we are shifting it and then sending that sequence, shifting it then sending the sequence, so that the rotor rotate in clockwise direction, right? Now when the rotor rotates clockwise 360 degree, how much degree of rotation would have taken place? This permanent magnet would have rotated 360 degree, but the shaft connected to that rotor would have rotated only by one step angle, by only one teeth. Means if you have 200 teeth, out of 200 teeth, one teeth would have rotated. Or you can say that 360 by 200, how much is that? 1.8 degree shift would have taken place, right? So how many times you need to have this sequence in order to make 360 degree? That you will have to calculate. Before that, come back to program. We'll see what needs to be done here. See here, move 66H into accumulator. That's what we had done there. And from accumulator I am sending it to port 1. Why am I sending it to port 1? Because it is port 1.7 to port 1.4 which is connected to stepper motor, and the values that you send here are going to energize and de-energize the stepper motor. Therefore, we are sending it to port 1. Once it is sent to port 1, I'll rotate left the accumulator content. Means what? I am keeping the next sequence ready in accumulator. Later on again I'll send it to port 1, right? So what is the next sequence that I need to send to port 1? It is whatever accumulator content is to be shifted left by 1 bit, right? Therefore, I am going to rotate left the accumulator content by 1 bit and then keep it ready, so that the next sequence I will send next. Okay. So once I give the value to port 1, the moment port 1 is fed with the value, that value flows, and that if it is 5 volts it becomes 12 volts and energizes, and thereby it rotates the rotor to whatever angle it is required. It operates. When it operates, it needs a delay. It's not that you continuously bombard with the values. The stepper motor will be slow. Therefore, you need to provide a delay between the two sequences. Always remember this. The more the delay you give, the stepper motor will rotate very slowly, like this, like this, like this, like this. Okay? If you give delay, lesser delay, it will rotate like this, faster, but it will be jerk. It will go like this and come back half. It will go like this, come back half. So it always rotates in a step, right? And between the two sequence, you need to provide a delay. Therefore, you call for a delay. So once you provide a value and then keep the next value ready and then go for a delay. There is a certain delay happening here. It jumps to a delay program. The delay, once this delay is done, it returns back. Returns back where? Returns back to exactly the next equation, sorry, to the next instruction from where it had taken a jump. So it comes here, S jump to back. Where is back? Back is here. You need to provide now a second value, right? So you have sent the first value, you have generated the second value, you have kept the second value ready, you have gone for a delay. Now we should come back and send the second value. It is such a simple program, right? So like this, you keep in the loop, you keep giving the sequences just by rotate it, give the sequence. Rotate it left, give the sequence. Rotate it left, give a sequence. So like this, if you keep on giving these sequences like this, now this program is written for making the stepper motor rotate in clockwise direction infinitely. There is no stoppage here. You go on giving the sequence, it goes on giving the jerks, right? So this is an infinite clockwise rotation. What you would want to do if you would want to have anti-clockwise rotation? Now you can think, what should I do? Come here. Again we started from here, right? And we made the rotor rotate like this, and it was clockwise. Now if I want the rotor to rotate in anti-clockwise, what should I do? After energizing B and D, I should not energize B and C. I should energize D and A. I should go in opposite direction. Next, energize A and C. Next, energize C and B. Next, energize B and D. Means I should go exactly in the opposite direction. If this is the sequence flow that I give for the clockwise direction,